Anatomy and Physiology Tutorials, Blood. In this tutorial, we will cover the basic understanding of the components of blood, blood types, and permissible blood transfusions. We begin first with the components of blood, which is a mixture of liquid and solids. 55% of blood is the liquid portion known as plasma. It is mostly water, but there are also plasma proteins such as clotting factors and antibodies, electrolytes, which function in osmotic balancing and pH buffering, and materials that are transported throughout the body such as dissolved oxygen and carbon dioxide, respiratory gases, nutrients such as amino acids and sugars, carbohydrates that we receive from the digestive system, and also hormones from the endocrine system, to name a few. The other 45% of blood is the formed elements: erythrocytes, red blood cells, leukocytes, white blood cells, and thrombocytes, platelets. Erythrocytes function in transporting oxygen and carbon dioxide throughout the body. Leukocytes function in defending the body against materials which our body recognizes as foreign. Thrombocytes function in forming blood clots, known as coagulation, in broken blood vessels so we don't bleed to death due to a small cut. Blood typing. Do you know your blood type? What does it mean to have blood type O positive or AB negative? Let's discuss the different blood groups. One's blood is typed by checking for the presence of specific glycoproteins which are found on the surface of an erythrocyte's membrane, or we can say your red blood cell's membrane. These glycoproteins are known as self-antigens, so your body recognizes these as you or self, and your body's immune system does not attack them. There are 4 blood groups: A, B, AB, and O. Seen diagram here are the 4 main blood groups. Let's look at blood type A. See the A antigens found on the surface of the red blood cell's membrane? Type B has B antigens. AB has the A and B antigens. But looking at blood type O, there are no antigens on the surface of the red blood cell membrane. Antibodies against foreign antigens are found in the blood plasma. So if someone has blood type blood type A, anti-B antibody is found in the plasma to defend against B antigens. Type B has anti-A antibodies. Type AB has no antibodies because it has both self-antigens. But look at blood type O. It has both anti-A and B antibodies because it has neither of the A nor B antigens. Think about it this way. Antibodies are the fighters for what your body does not know or is not self. So if you are blood type A with the A antigen, you don't know the B antigen. So you need a fighter against it, anti-B antibody. It is best to receive your blood type if you are in need of a transfusion, but some of you are able to receive donor's blood that is not your type. But what happens when you receive blood from an incompatible donor? The recipient's antibodies can attach to several donated red blood cells and bind them together in an antibody-antigen complex. As seen here in this diagram, the donor has blood type A. Therefore, the red blood cells have the A antigen. The recipient, there on the right, is of blood type B, thus having anti-A antibodies. Upon transfusing the donor's type A red blood cells into the recipient's anti-A antibodies mount a defense against the foreigners. The recipient's antibodies agglutinate the donor's red blood cells. When deciding whether a blood transfusion is permissible or not, remember this: it is the recipient's antibodies that agglutinate the donor's red blood cells. Remember, agglutination is the clumping of the mismatched red blood cells when the recipient's antibodies react against the donor's antigens. Take a look at this first example. Type A blood is the recipient and type B is the donor. It is the recipient's antibodies that agglutinate the donor's red blood cells. Ask yourself, does type A have an antibody against type B's antigen? Yes, it does. So this blood transfusion is not permissible because the recipient's anti-B antibodies will agglutinate the donor's B antigens. Next example. Type O blood is the recipient and type AB is the donor. Again, it is the recipient's antibodies that agglutinate the donor's red blood cells. Does type O have an antibody against type AB's antigens? Yes, it does. So this transfusion is not permissible because the recipient's anti-A and B antibodies will agglutinate the donor's A and B antigens. Next example. Type A blood is the recipient and type O is the donor. Does type A have an antibody against type O's antigens? No, it does not. So this transfusion is permissible because the recipient does not have anti-B antibodies and the donor, type O, does not have a B antigen. No agglutination will occur. Last example. Type AB blood is the recipient and type O is the donor. Does type AB have any antibodies against type O's antigens? No. And type O does not have any antigens, so this transfusion is permissible. Yes, the recipient does not have antibodies, nor does the donor have antigens. It does not matter that type O has both anti-A and B antibodies because remember, it is the recipient's antibodies that are doing the agglutinating or the attacking. So AB blood can receive all blood types. Therefore, we refer to it as the universal recipient. Type A can receive type A and type O. Type B can receive, of course, type B and type O. But type O can only receive type O. It donates to everyone, though, so we refer to it as the universal donor. If you know your blood type, you may know that you are not just blood type A, you're blood type A positive or A negative. There is another blood group known as the Rh blood group. The presence or absence of the Rh antigen is the basis for typing one's blood as positive or negative. Blood types AB, AB, and O positive each have the Rh antigens on the surface of the red blood cell's membrane. The plasma will contain no Rh antibodies. A, B, AB, and O negative blood types do not have the Rh antigen on the surface of the red blood cell's membrane. The plasma will also contain no Rh antibodies. This is the difference. It is only if the person has been sensitized or has been in contact with the Rh antigen will an Rh negative person have anti-Rh antibodies in the plasma. Back to the permissible transfusion graphic. We understand that blood type B can receive type O, but what if we look at the whole picture and we are dealing with type O positive and B positive? This transfusion is permissible because both blood types have the Rh antigen, and we have already established that type B can receive type O. But what if the recipient is type B negative and it's to receive the type O positive blood? The first transfusion will not cause a reaction because type B negative blood does not normally carry the anti-Rh antibodies. But after this first transfusion, type B negative blood will begin to produce the anti-Rh antibodies that will agglutinate Rh antigens in any subsequent transfusions. Let's look at another example of the recipient being type AB negative and receives type A positive donor blood. The first transfusion will not cause a reaction because type AB negative blood does not normally carry the anti-Rh antibodies. But after this first transfusion, the type AB negative blood will begin to produce those anti-Rh antibodies that in the future will agglutinate Rh antigens in any subsequent transfusions. If a man who is Rh positive and a woman who is Rh negative conceive a child who is Rh positive, the woman's body may manufacture the anti-Rh antibodies that attack future Rh positive offspring. This first pregnancy would not be of concern. If some of the first baby's Rh positive blood is transferred to the mother, she is now sensitized to the baby's Rh antigen and will begin producing anti-Rh antibodies. Again, the first baby is not harmed. The concern lies with the subsequent offspring who also may have the Rh positive blood type. The mother's anti-Rh antibodies may cross the placenta and will agglutinate this baby's red blood cells, causing erythroblastosis fetalis or hemolytic disease of the fetus and newborn. To prevent this, women who are Rh negative receive an injection of a drug known as RhoGAM, which shields any Rh positive fetal cells that would sensitize her immune system into producing those anti-Rh antibodies. Subsequent Rh positive offspring would then be safe. So when considering a blood transfusion, the true universal recipient is AB positive and the true universal donor is O negative. Now, are you more interested in finding out your own blood type if you don't know it? This concludes the blood tutorial.